So we have finally finished our EECS3215 final project. This video is more of a demonstration of what we have achieved, and we're gonna also explain some of the coding and the logic we use. So we have a group of four. Mohammed, which is the guy in the blue shirt, Shanez on the right corner, Honda, which is me, and Sam, you can barely see him. He's on the right corner of the screen. There's no coffee maker in our group. Everybody works really hard. And yeah, so let's get started. What our project is about is we use DHT11 connecting to Raspberry Pi. And DHT11 is what we use to collect the data for temperature and humidity. So what it does is the system will keep monitor. So if we receive the data, it's going to output the data to a CSV file. And if not, it's just going to display on the console saying sensor failure, check varying. And just going to keep checking and keep checking again and again. It's only going to stop when we call the program to stop. And then we're going to have a separate Python file, which is we use called Spark streaming. What it does is use Spark to process the data and it monitor the real-time data. So once the temperature go above 40 or the humidity go above 80, because that they'll be abnormal. So it would then send email notification to the user. And if not, they're just going to keep monitor the data. The ideal use case is, let's say if your house is burned on fire, but you have your Raspberry Pi and your DHT11 connect to each other, you will be notified immediately, like in the first place. Let's hope this never happened, but if this happened, you will be notified immediately. Right? So how we connect to it, you can see this red wire here, which we connect to port 4. This is the power supply, and then the black one is the ground. The purple one is the data output. So this one connect to DHT11 and work. And you can take a look at our demonstration videos. So we finally set up the DHT11 with Raspberry Pi. We connected with the 5V and the ground here with the red wire. The orange wire is the data output, which we connect. So this is gonna record temperature and humidity. And what our project is about is once this go above to a certain point, we use Spark to process the data, and it's gonna send us emails. So I'll briefly show you the code here. Spark streaming. So we have two files. One is called Spark streaming. What it does is it creates Spark session, and then it processes data at the same time. For the email sender, we set it to be Sam. Sam is one of our teammates, and the password is generated by Gmail, which I will show you later in the video how exactly we get this passcode. The recipient will be mine, which my laptop. Let me just open. So later you can see this is my email account. Later, when I use the lighter try to burn the DHT11, I will receive alert. Okay, so and I remember we set the temperature to be above 40. So once it go above 40, it's gonna send me alert. Oh, another file we have is DHT11. In this case, we use Adafruit library, and we process it as a timestamp, temperature, humidity. So we can see the timestamp, we can see the temperature, we can see the humidity. So it reads the data and then output to us. So let me try to run it. Oh, by the way, the reason we use, so originally we tried to use one Python file, which is called run both, to run both of the file, but it turns out it doesn't work that way. And I guess it's because like it worked that way, but Raspberry Pi couldn't handle such complicated tasks, so we couldn't do it. But later in the video, I'll demonstrate like how we plan to use it, but it did not work. So right now we're gonna use two command windows to run. One run DHT11, another one run Spark streaming.py. Right. So yeah, so this one I'm gonna run Python Spark streaming.py, right? So this will create a Spark session, and this one we're gonna do a Python DHT11. What's happening? Oh, Python DHT11.py. Yeah. Okay. Perfect. Yeah, it's reading the data. Okay, so you can see that this is temperature, this is humidity, this is the timestamp, and it's following the time right now in this computer. So let's say if I use a lighter to burn it, I burn it like this. Yeah. And then the temperature will slowly drop. As you can see, when I burn it, it increases. When I drop it, stop. And the PySpark here is gonna see this data and gonna output me. So it's gonna send me an email alert very soon. But it takes some time. Like I said, Spark runs really slow in Raspberry Pi, I guess. So let's just wait. Let me just stop this for a while. I think this really slows the process. No, perfect. Oh. So sent successfully. Oh, I see. You can see the emails here. And if I'm not mistaken, it's gonna keep sending emails. So if I refresh this, 3, right? And it's just gonna keep sending because there's a bunch of new stuff because it go above 45 at 11 o'clock. Remember when I burn it? And it's gonna process all this data. So if I refresh, it's gonna keep giving me new data. I should probably stop because Google may detect this as a spam. So yeah. Yeah, so basically that's our project about, and I'm gonna explain the coding in detail in the next slide. Yeah, so why do we use Spark? So we use Spark because first of all, it processes data more efficiently. So think about Spark like this. Spark is something like you have one master and you have several slaves. So one master and control several computers. Each computer will perform their own task, and then they will perform their own one, and they will gather by the master. But to be honest, we never actually use this functionality. We use more of the structured streaming, which is it will monitor the data in real time, which is also why Hadoop cannot achieve this. Hadoop can only do batch processing, like it can only process the data one by one. Also, Spark is a lot faster than Hadoop. So Spark process data in memory, and Hadoop, I think they process the data in disk. So that's also why we use Spark. Also because we want to prepare, nowadays Spark is commonly used among data engineers. We don't have much experience in Spark. That's why we want to prepare ourselves for future career. So we want to get our hands on Spark. And let's take a look at our code here. So I open it in a separate folder. So we have two Python files. One is called DHT11, where we use Adafruit library. This is really powerful. This library will just read the data by itself. Everything is set for you. You connect to the pin, and then it will automatically detect the temperature and humidity. So we set up a CSV file, which is called sensor data.csv. We store this to a folder. And this header is what we're gonna put in the CSV file. So what this header does is, look here. So if this file does not exist, if we do not see this file here, then what we're gonna do is we're gonna write to this file, and the first row is gonna be the header, which is the timestamp, temperature, and humidity. And then for the later part, so if it's already exists, it's just gonna keep logging the sensor data, in which we call this library that had a read function to read the DHT sensor and DHT pin. Remember earlier I talked about in the videos that we set our pin to be 7. That's the data output part. So in this case, the DHT pin is 7. And then if we can see the humidity and temperature, we're gonna process it by showing the timestamp, showing the temperature, and showing the humidity. You have already seen this in the video. Yeah, and I'm just gonna keep writing new rows to the CSV file. And if it's also going to print in the console that if it's a success, we're going to see the log data with the data. And if, let's say if this humidity is none or temperature is none, that means that the data is not being recorded. We're going to display sensor failure check varying. This is going to keep running until we call it to stop. So it will just keep reading and keep reading, keep reading. And we have a separate Python file which is called Spark Streaming. What Spark Streaming does is, okay, let's look one by one. So earlier I talked about the email part. How this, and I said that I'm gonna talk about how we get the email password. So I will demonstrate it here. So let's say if you open the web and you go to your Google account, you go to your Google account settings, come to your my account.google, click sign in. And then you will be, you here look at your Google account setting UI, and make sure you turn on your two-step verification. So once this is turned on, you come here, search for app password. Yeah, app passwords. Click on this one. It's gonna ask for a password. Press next. Here, you wanna create your own app name. In this case, I'll just put it as Honda. Create, and this 16 letters is what we're gonna put in our Python file here. And this also where the password is from. So we're gonna copy paste this thing. Yeah, to here, right? And there's no space in between, so you might want to modify this part. And then the written email, as you can see in the demonstration video, is my email. Yeah, so send them email alert. It's gonna process it from to subject. It's pretty self-explained, I think. So for the Spark session, so to use Spark, we need to first create a session because that's just how it works. And then we want to predefine the schema. And remember earlier we predefined 3 headers as timestamp, temperature, and humidity. So here we want to define these 2 because this later going to be used for the data frame. And yeah, read stream is the function that we use to monitor the real-time data. So it's going to keep reading what's being inserted into the Spark. And once then once the temperature go above 40 here, or the humidity go above 80, we're gonna set the data frame to be like alert in the end, and otherwise it will be normal. Right? This part we process the alert, so this is gonna look through the data frame we created earlier, and then if it's alert, we collect the things and we send those emails. And what this here does is it will call the process alert function for each microbatch of data. So what it does is it will keep the Spark application running and actively monitor the data. And this function will, so await termination means like it will only stop when we call it to stop. It will not stop by itself. For example, if your app accidentally closed or your console accidentally closed, it will not stop. It will only stop once. Two scenarios. So one is if you switch off your hardware, you turn off the Raspberry Pi, it will stop. Or secondly, you need to manually to write exit in the Spark UI to call it to stop. And in the video, I also mentioned that we have a run bolt file, but we didn't actually use it eventually because in the beginning when we created those codings, we were thinking like how can we run 2 files at the same time? Like we never think about to use 2 command lines to PowerShell windows. So we say, okay, how about we create a Python file? We use a library called subprocess so we can process the data at the same time, right? One is called dht11.py, another one is to call the Spark streaming.py. But it turns out that this worked, but this doesn't work on a Raspberry Pi. The reason is because the Raspberry Pi could not handle such complicated tasks. I think maybe one of the reasons is because it takes too much memory. That's probably why I'm assuming, because Spark is already occupying lots of the memory space. And then when they run 2 times, it's become really much complex. Like the time complexity and the space complexity increase a lot, which Raspberry Pi could not handle anymore. So yeah, so eventually we did not choose this idea. So what we did is we just open two common shells and we run these two separately. Yeah, and that's coming back to the presentation. That's pretty much of our presentation. Some of the reflection we get is we realized that DHT11 cannot run for too long. So we had DHT11 run for 2 hours and it's actually burned out, as you can see from the video here. So we've been running for 1 hour and 30 minutes, about 2 hours, and we can see this thing is burning like this. So yeah, like I said, it's maybe to put it in the bedroom to monitor the temperature is not ideal. So yeah, and that's pretty much for our demonstration videos. We put the majority of our thinkings into the final report here, where we document some of the literature review we have done. Initially, we thought we want to implement machine learning algorithms, but then the whole Raspberry Pi when they run some linear regression models, it just stopped and then it crashed. So I guess maybe it couldn't handle such complicated task. And then we also document how it's